then you have output, then we have, if you remember our sensors, this thing go feedback here. So we call this RS. RS. And you have called it GCS. And you called it GPS. And you called it CS. And you called it HS. And I will define for you these things. RS is basically your input reference. Your input reference. CS is your controlled output. Controlled output. HS is your feedback sensor. GCS is your control device. GPS is your system to be controlled. Now we have this. So we moved another step. What we did, we put everything in terms of simple. Don't write it. Just use it. Straight to it. Remember, we are laying down the foundation of a methodology which will help us to conduct our control analysis. So we are defining various kind of symbols, various kind of systems where we have input, output. We are looking at the transient, inputs which are coming from environmental perturbations. We want to take care of those. We want to minimize the errors between the input and output. Also, we want to minimize the transient time, the reaction time, and we want to make sure that we understand that what happens if these systems are more than one, or where the feedback is taken from. Maybe it's taken from the exit, or maybe somewhere in the middle of the system. And where this external environmental perturbation appears. Does it appear at the beginning? Does it appear in the center? What to do? We learn to find out the transfer functions of these systems. Once we have control over these systems, then I believe that we can really simplify everything, and then we can see how to use the control theory to do our job. So this is really the initial steps. The first step was to define what type of systems we have: mechanical, chemical, electrical, any system. And I gave you an example of a mechanical system where this is the input, this is the output, right? So we have then symbolically that we have defined a circuit in which open loop, there was no feedback. There is a problem with that because it is really insensitive to, right? It is very sensitive to environmental perturbations. In order to make it insensitive to external disturbances, we have defined the feedback system. And in order to simplify our life, we define those variables or notations, we call it. So we stick to that. Now to do some little bit more work and say how to combine everything to get our transfer function from here to here. Of course, our transfer function will be output over input. Right? That's what our transfer function is. But we have to look very carefully that how we can write in terms of these variables. Okay, so now I will tell you a very simple thing. So we will define the transfer functions. So remember that you have this, the transfer functions overall, and I will separate everything and then we'll try to combine them. So let's write down. Again the block diagram, but now you have a little bit more control, over your strategy. So let's say the transfer function of the system so it's called GS, output over input. We can get transfer functions of a simple system. So if you have a simple system GS here, this is the transfer function GS, this is your input, this is your output. So these are all transfer functions. So the symbols which I wrote, you have a controller. So this was your simple system. This is your controller. And here was your input for the controller, and here was output. So the last time I put a symbol here, GCS. So GCS is actually the transfer function. So I replace that by its transfer function. That how this controller is changing input to the desired output, and the transfer function is denoted by GCS. It's a transfer function. Then we have a sensor. So we can have a sensor, and then we can have input, then we have its transfer function, and then we have output. And this transfer function is HS. Again, it's input over output. So if you have a complete